Hello. Today we're going to test the thin lens equation. We're going to see if we can calculate the focal length of a lens by doing an experiment involving the lens equation. What we have here set up in front of you is an optical bench. It's basically a ruler on a stand that allows us to place a lens, which is in the center there, a screen on the right, and an arrow target that is going to be illuminated for the lens to focus. We're going to show you this a little bit differently up close, but first let's progress to the blackboard, or in this case the whiteboard, where we can view the thin lens equation. And as you can see, we are in a laboratory, and in order for us to explain this thin lens equation, we have to look at it as I drew it. On the left is the two arrows at right angles to one another. That is our target. That is what's going to be lit up for the lens to project. We have the lens in the middle. I drew it as a double convex lens. And then we have on the right our screen. The lens is going to invert the image and project it onto the cardboard screen. So for our purposes, the FO is the distance between the object that is illuminated to the lens. And FI is the image distance. It's the distance from the lens to where the screen focuses the image. So now we are going to show you the optic bench as it is lit up. Okay, we are now behind the optic bench where the light is, and we're going to show you, with the room lights out, and just based on the light from this lamp, we're going to show you the image that it is illuminating. You see the two arrows. That's a metal plate with the two arrows cut out. Now the lens is the next thing down that we're going to look at. We know the focal length of this lens, but I'm not going to tell you because you're going to use the thin lens equation to figure it out. So now we're going to progress to the screen. And you can see as I zoom in on this two arrows there near the bottom is the image from the lit arrows that we just showed you. Now what we need to do is focus it so that we get good, sharp, clean arrows, and then we're going to measure the distance between the object image on the left and the lens on the right. And we have a ruler here to do that, and we've already done it. I'll tell you those figures in a moment. But now we're going to move the screen a little bit so that we get these arrows as sharp as possible. I'm putting my hand here, and I can move the screen in and out, up and back. And as you can see, the focus changes on the arrows as I move it. That's about the sharpest place that it will be. And I have pre-measured these. We're going to back up and show you again. This is the image illuminated, followed by the lens, followed by the image that the lens has projected. And as we look at the optic table, you see there's a separation distance between the lens and the object on the left, and there's a separation distance between the lens and the object on the right. We're going to go back to our equations, and we are under extreme low light, so this camera is really doing an excellent job. You can see the FO is the distance from the lit object on the left to the lens, and then FI is the distance between the lens and the image that it creates. Again, let's look at the first formula, the actual thin lens formula. And what we have here is 1 over FO, which means the distance to the object, plus 1 over Fi, which is the distance from the lens to the image it creates. I means image. And that will equal to the reciprocal of, which is 1 over, FL, which is the focal length itself. That is the equation that we are going to use. And we're going to give you the figures for these numbers. Now, for these distances, sorry. FO is equal to 41 centimeters. It came out pretty exact. FO is 41 centimeters. FI is 37 centimeters. 37 centimeters. What you are to do is to figure out FL, which is the focal length, based on this setup.